great pleasure to welcome opening the Accelerator Day this afternoon, Dr. Simon Locke, who are taking you through the evolution in Wi-Fi and mobile offload. And with that, please give a big round of applause to Dr. Simon Locke.
What's up, guys? I'm your entertainment for the next 15 minutes, even if there's absolutely nothing useful about what I say. Hopefully, at least you will come away a little more awake. So, they asked me today to talk a bit about how we go and do things with Open LAN and Open RAN together. Specifically with Wi-Fi, how can that help your Open RAN stuff work together? Well, you know, where are we at right now is disaggregation. And disaggregation and open systems are kind of what we've agreed are a good thing, right? Pretty straightforward. I've got hardware, I've got software, and I should have choices. And that's not to say that my choice should always be disaggregated. Obviously, I should be able to choose vertically integrated solutions. That's part of my choice. But if I choose to be disaggregated, if I choose to have the hardware and software separated, then I can go and accomplish a set of certain things, some of which we'll talk about. But specifically, one of the things I want you to think about is how this affects your subscriber base. How does this affect the revenue you can generate, specifically in high-density markets? Now, when we have a radio access network in a low-density market, we kind of really understand how to do that quite well. In fact, I would say that the hardware is really well optimized for that. If I go and I put up a radio head and there's only like 50 people on it, that's a controlled problem. If I put up a radio head and there's like 300 people on it, I am in deep trouble. And this is a natural occurrence of something called the gain bandwidth product, right? What's going on here is that given a certain state of technology, we have to make a trade-off between how far we can go and how much stuff we can put through there. And you all know this inherently. Like if you think about medieval times, right? We could have a courier on a horse that could carry a scroll, which is a lot of data. Or we could have a carrier pigeon, which is not a lot of data, but it could go further. And as the state of technology improves, now we can send a very small message to Mars, or we can send a multi-terabit message, you know, with a fiber optic cable, whatever distance that can go, right? And so we all know this inherently, but somehow, when it comes to the RAN and the WLAN, we seem to have forgotten this. Right? So for a while, a lot of us are doing weird things like, oh, let's just go and put everything on the RAN. Well, that doesn't work. It doesn't work because physics is like the law. Communication theory has told us that that's never going to work. And so what we have to consider is, how are we going to solve that problem in a sensible way? When we increase the density of what's going on, we have to recognize that perhaps the most important thing we have to do is separate the subscribers from the hardware. Nowhere else is this more important than in fixed access networks. It's very clear there. In fixed access networks, every single sub is tied to a residential gateway. Therefore, your revenue, what you can make, is tied to how quickly you can put those residential gateways out. In radio access networks, this is not true. In radio access networks, my subscriptions are tied to typically the quantity of UEs. Well, in that case, that's great because I can put up this one tower and I can get my 100 UEs on it, and therefore I'm a very happy person. I can scale my revenue independently. How could I possibly do that with fixed access networks? Well, we're here talking about Open LAN, and with Open LAN, there's a pretty reasonable way to do that. And that would be to build on top of the existing Open LAN infrastructure software-defined access networks that allow you to go and put the subs into software systems for each person that are completely independent of the hardware. This solves not only this problem, but it solves other problems. It solves the problem of how do you use a single unified backend in order to go and backhaul things like small cells, or be able to do RAN offload, or be able to support multiple tenants on the same physical. So by applying the same disaggregation concept, right, where we were saying before, oh, we're going to separate the software from the hardware, I'm saying we want to do that again. This time what we want to do is we want to separate the subs from the actual hardware as well, and that allows us to get to a place where we're trying to do what I'm showing you here. The other interesting thing about this approach is that not only does this solve the problems that I'm sort of presenting right now, which is if I have some kind of fixed access network, right, and I have some kind of set of subs, I also can solve problems for those subs that have yet to be invented. And the reason for this is quite simple. Consumer electronics are always targeted for the same platform, and that is the physical residential gateway. And as a result of that, anything that we build that tastes and smells and looks like a physical residential gateway will be compatible with that. So next year's drone or whatever strange thing they come up with, that will work if what we do is we build software-defined access networks that follow that pattern. The way that my company, RGNets, has decided to do this is by building bookends. And at the bottom of those bookends, the initiator, are open LAN products, things that you can see across this exhibit floor. At the top is the other bookend, and that typically is a set of servers running things like NVIDIA DPUs, which is other stuff that you can see all around here. We aimed on these various booths that you see. And by putting these two together, this allows us to build software-defined access networks for any fixed access network that you can imagine. That might be, for example, OLT, ONT on POD, that might be cable modem CMTS on DOCSIS, or it might be active Ethernet. And at RGNets, we actually have all of these scenarios deployed at national scale. Specifically, what we've been doing over the last year or two is going and turning open Wi-Fi APs into service-aware software-defined access network initiators. And what we mean by this is we mean that every single time something is ingressing into that AP, we classify it, we encapsulate it, and we move it on. And we even move it on depending on not only who or what is going on, but also the policy and how the underlay is behaving. So if there's a problem with a particular concentrator, we can use a different one, for example. In addition to the more classical examples of, for example, we have a person paying a different amount of money, or some of the other things that I said. For example, if you're going to use RAN offload, or you're going to go and use it for backhaul of small cell, all of those things can be driven to different places. And as a result, you have a single unified underlay, and that unified underlay allows you to establish a national scale encapsulation, decapsulation, which allows you to go and have a complete independence of what your revenue stream looks like with respect to the hardware. Furthermore, one of the things that we've been working a lot on is getting to the place where the open Wi-Fi systems are able to be expanded and accumulated in ways that are fully automated. That includes the use of mobile apps to go and drive various systems, dashboards, and things like that. And we're also nowadays layering in even AI LLM technology. On the concentrator side, what we've been doing is trying to drive the cost and scalability of that down. Normally, when you go and you try to do any kind of concentrator, any kind of aggregator, you're typically talking about ASICs. And you're typically talking about hundreds of thousands of dollars of ASICs, plus software licenses on top of that. What RGNets has been doing is taking all of those open LAN, open Wi-Fi initiators and bringing them all to a centralized place, and in that centralized place, implementing it using NVIDIA accelerated computing, using DPUs that are commercial off-the-shelf, software that we provide, creating a disaggregated solution with an unmatched level of agility. And that unmatched level of agility allows us to implement things for national scale customers that other people have only dreamed of doing. This includes, of course, the offload and the backhaul of small cell scenarios. The horizontal scaling of this is also incredibly powerful. You can just go put more DPUs. If you want to go scale a typical aggregator, you need to go buy another chassis, another $400,000, and then another go and put another license onto that. What we're saying is, you want to scale this horizontally, you just slap in another DPU. And every single person that's selling you a chassis wants to sell you a chassis with another PCIe card, and certainly the DPUs are way more affordable. When you put this all together, the final result is absolutely incredible. It brings the capabilities that you would expect from the individual residential gateways or individual business gateways up to the concentrator. So rather than having all of the functionality that you expect tied to a piece of hardware, which of course means that your revenue expansion is tied to that piece of hardware, what we have going on is the complete opposite. You can go and scale your revenue independently. You can have the residential gateway features such as UPnP. You can have wired and wireless integration across the entire plant, and it is completely seamless. And the reason for that is because we have completely disaggregated the system, right? We're using every piece of hardware only as an initiator of the network. We're concentrating it on a disaggregated solution. The net result is something which is beautiful for the customer. They can be anywhere on the network, they can do anything they're used to doing, and this is particularly fun in high-density scenarios. So think about like a multi-tenant scenario, an MDU, an apartment building, an apartment complex, or a smart city. This means that you as a subscriber can walk around anywhere and your public IP address remains the same at scale, potentially at a national scale, especially in Europe here, where the national scale is a little bit smaller, right? In the United States, that's a little harder, but potentially it could be done at least up to a regional scale. This also is an amazing thing for the operator. It's an amazing thing for the operator because what it means is that the operator can now scale the amount of money they make completely independently of the amount of hardware they install. So this is a beautiful win-win situation, and it's made possible because of the beautiful nature of the Open LAN project. Because the Open LAN project allows people like me and you to access the source code, make changes, and do these kinds of things, we can build this kind of a beautiful solution by modifying what's out there to be able to support use cases like this. This is not the only use case, obviously, it could support. It could support an uncountable number of those. But all of that is enabled through the opportunities that are created because of this Open LAN system and the participation of everyone in there, including you guys in the audience. So, net result is what we happen to be doing with this technology, the Open LAN, and I want to talk about this week, is this concept of a software-defined access network. A software-defined access network for every kind of fixed access network, be it OLT, ONT on PON, DOCSIS, or active Ethernet. And we want to provide the ability and agility to go and support anything that you could possibly imagine. As a result, both the subscribers and the operators are going to benefit from that. Thanks for listening, guys. Hope you guys have a great lunch.